All right, up next is Team Horizon. Go.
Hi, I'm Aryan, this is Tony, and this is Marion. We are Horizon. And the problem case that we decided to target was problem case 2, developing a housing affordability index and creating an AI tool that can help you navigate the data we get from it. Now, when we were developing this, some of the goals that we had in mind were to help anyone who looks like any council person who looks at this. They should be able to easily identify the data. They should be able to figure out which neighborhoods in Jacksonville are most burdened and figure out, based off the characteristics in that data, what changes they have to implement to improve that index percentage. And be able to compare our index scores with other index scores to see if we're aligned correctly or if our model is making up numbers. And I'm going to pass it off to Marion so he can explain how we did that.
Yes. So, beginning with our data set, we were looking at 207 census tracts for the City of Jacksonville. We decided to focus on Jacksonville, so we figured we might get, we wanted to have an index designed for the city council people of Jacksonville, for the government workers in Jacksonville. So yeah, we initially put down 215 features, and then we feature engineered that down to 36 strong predictors. And if you look behind here, you see we have very strong correlations with our target variable, which I'll get to on the next slide. So we decided to use an ensemble of models in order to produce a housing affordability index. Yes. Yeah, so we decided to use a regression model, Marion Forrest, and neural network. We decided to use this ensemble so that each model will learn different relationships in the data. And then we wanted to have a linear model so it was easy to pull out the relationships that were learned, and that way government officials will be able to pinpoint exactly what is influencing affordability in a given area. And to train our models, we use the pre-existing housing and transportation index as our target variable. And we decided to take this approach for 2 reasons. One, by training based off of an existing index, it gives our index a baseline level of accuracy, or it gives our index parity with an existing one, which allows for council members, although we are only looking at Jacksonville data, they can take our index score and we are able to convert it to a comparable index score on another index. So even though our data is looking at Jacksonville, city council people can take our score and still compare it against, say, Tampa, Atlanta, or other cities. Yes. So in isolation, these are the R-squareds for our model, and then our aggregate model had an R-squared of about 0.84, and the way to interpret that is our model was able to accurately represent and comprehend about 84% of the relationships within the data that were influencing housing affordability.
I'm Tony, and we decided with Marion's amazing data, how would we intuitively show this data to the city council people? And in doing so, we decided to create a live demo, which is going to be a web app that accurately shows zip codes correlating with our scores. So for instance here, if I type in Jacksonville, and we click on the city and search it, it's going to load, it's going to make API calls to our backend where all the training model data was stored. And once it loads up, we're going to see scores for each and every zip code correlating to Jacksonville, as you can see here. And this gives us an overarching view of our score. And to explain more about our Horizon score, we kind of wanted to model it with the FICO score, and 0 being the worst and 1,000 being the best. And this is the average of all the zip codes in Jacksonville that culminate to our affordability index score. Now, if we want to zoom in, let's say 32256, we can see here that it is a fair score And we have the positive and negative factors here that kind of indicate why that is. So this is very intuitive for city council members because they can review this score and they can see what's driving the housing affordability index within it. And then we also have down here our model scores, which represent the reasoning as to why it came up to this average score. Now, let's say we wanted to compare scores. Maybe a city council member wants to see a different score from a different zip code. Well, we can also compare it here. I'll do 3224, for example. And there we go. We have a side-by-side comparison as for our affordability index, and it will actually show what's driving the difference between the two. So now policymakers can make an informed decision as to why this one is higher than the other and what they need to do to drive that affordability index score higher. I'll go back to Marion to explain more of how they can review this data to better interpret it.
Thank you. So, looking at this info here, if we want to observe the positive factors influencing our score, for example, we have the proportion of homeowners not cost burdened, but a brief description of what this means, and then the way you would interpret this is about 78% of homeowners in this zip code are not burdened. And you can interpret the weight as saying if we can increase, every increase in that will drive the index, will drive housing affordability, will drive housing cost down by 6 points. And then on the negative side, it's the inverse. For the weight, every increase in the value will drive housing costs up. So in this example, if you can scroll a little further down, for occupancy rate, we see here our value is 0.92, so that's almost 100% occupancy. So supply is very constrained. When supply is constrained, that means demand is really high and prices are very high. So that's how this one is influenced. And then, as I mentioned before, we were trained off of the Housing and Transportation Index. So this is the equivalent H&T score. So now, a city council member, if they want to compare this zip code to, say, a zip code in Tampa, they can look at the Tampa H&T score, and they can do a one-to-one comparison based off of that.
And once you see all that data and you're able to analyze it, we also implemented a chatbot that takes everything on the screen and along with all the documents we uploaded to it regarding past decisions and past policies passed to help with housing affordability, it can help give you suggestions on based off of the weights and what's wrong, what's good. It can give you suggestions on what you can do in that neighborhood to help affordable housing.
And as you see here, I'm currently prompting it for the current zip score and our horizon score. It is going to take a second as we are making API calls directly to GPT, but here we go. We have the accurate data. It made a call and it correctly correlated the data that it sees on the screen. So it is validated data that policymakers can make intuitive decisions. If you want to hold the mic for a second. You can also ask it.
Okay. And while he's typing this in, we took about 40 PDF documents all around the US, and that's what we're basing our policy decisions off of. We got these from universities and government institutions, so we have a healthy mix of good data.
Yeah, so now we're gonna query it of, let's say I'm a city council member and I want to inquire, hey, why is my score fair? How can I make it better? Well, we can inquire and make data-driven decisions with that RAG model that Aryan explained, and it will give us legitimate suggestions as to how we can increase this affordability index. And this is going to be very helpful for people who want to have an overlook, and then if they don't know how to approach it, there's an easy way to approach it using an AI LLM as an integration with validated data, so you're not just hallucinating. And yeah, that is our full demo here. I'll go back to our PowerPoint. Have a load up for a second there.
Yeah, so after putting together this tool and just messing around with it for ourselves, some of the key trends we discovered were particularly related to transportation. As you can see, the outermost areas of Jacksonville have lower scores. Sorry, time's up.
Yeah, so I'll get started here. This is fascinating. Definitely, I think could be useful for some of the government eyes, whether on the city council or just in a department, zoning, permitting, planning, real estate, housing, etc. What's your key? Your color code? I see a lot of greens and yellows on that, no reds. I know certain areas maybe should be reds, etc. And I see fair to moderate, and moderate looked lower than fair. So what's the color code and the general key from 0 to 1,000? Can you explain that a little more?
Yeah, so the reason why we have a lot of yellow and green is the range is very wide, but Jacksonville is very homogeneous in housing affordability. A full range, this would be a blue to red heat map, with blue being, I think, 800 and up, and red was 250 and below. So we designed for a much wider range, but Jacksonville just happened to be very homogeneous.
I think you explained this, but I think I missed it. Could you explain for the model the housing and transportation value? So you had that for other cities, not for Jacksonville, but you had the same inputs and you're predicting it, or just walk me through that one more time.
Yeah, so there is another index out there, the Housing and Transportation Index, which looks at housing characteristics and transportation characteristics to determine affordability for a given area. What we decided to do is it's a nonprofit organization. We pulled down one of their data sets, so we get the scores that they calculated for the Jacksonville census tracts, and we use those as our target variables to train our models to take our data and run the representations to match the performance, per se, of their index. That way you can have the comparable scores, and it gave us a more reliable target. Originally, we tried to use features from within the data set as our targets, but we didn't find enough really good predictors for that. So we figured we might have a better chance if we leveraged the effort of another group of people who already found a great index, we got a great score out of there. Then we can start looking at features from Jacksonville that can be combined together to make their similar predictions.
Thank you. And then one more real quick, the 50 points right there. Can you talk, or maybe scroll down a little bit too, if you can just talk about how that works?
Yes. So the scores are comprised of about 35 characteristics, and then we display the 5 most influential characteristics. So here, this one added 50 points onto the score. This one added 44 points onto the score, and then the others remove appropriate points. So our models output scores that are very similar to the H&T equivalent, and then we scale those scores to increase the range on them. So we have the 0 to 1,000. We figured that'd be a bit more interpretable, having a wider range, so you can have more fine differences between zones. So yeah, again, so this is the amount of points added or taken off of the overall score, and this is the actual value of the metric. And then this you can interpret as being the power, the level of influence this metric has on the score.
Thank you.
You are getting from regression model, right?
Yes.
Okay, so now I see that, you have also mentioned about other models, right?
Yeah.
What is the reason that when you try for explainability, you adjust based on one model, but how did you then use those models in your output? Like ANN, I saw Random Forest. What was the purpose?
We wanted to have multiple models so that each one would learn different relationships within the data. So we had about 35 tracks. We figured one model wouldn't be 35 features. So we figured one model wouldn't be enough to fully encapture all of that. So the idea is by having multiple models, each one can sort of spec into a certain grouping of features. And the reason why we chose to do these based off of the regression model, we figured it would be the easiest to explain how these features, it would be easiest to explain how the feature breakdown from a regression model.
So there are other methods also. Can you go back to your slides where you mentioned that architecture, and I saw that your feature importance is outside the models. Can you please explain to me, when you redefine features, right? Is this something you are trying to do, importance of feature in that state? That after raw data, when you say refined features, what do you mean by refined features?
Oh yeah, so the raw data was the initial 100 something feature
Yes.
data set, and the refined was when we,
so
all
now-
of our features were feature engineered, so we refined that down
Did
to
you
about
reduce the
30.
number of features from that raw data to refined features?
Say that again?
Did you reduce the number of features from raw data to refined feature state?
Yes.
Okay. So when you reduce, so that means you use some calculation for importance of features.
Yeah.
But that is outside the model. How do you know, or how did you decide that your model's feature importance exactly follows the same algorithm as you are trying to do? Because that's a very linear relationship. Probably you have used correlation or all sort of things, right?
Yeah.
So now how do you know that when you actually apply a modeling after that step, and if you pass the same input as a raw input, it will exactly give you the same results? Because if you have some modeling where it will not use linear relationship, for example ANN, right? So how do you know that your feature importance algorithm and the models like ANN are consistent?
Let me try to understand.
No, that's fine. That's okay.